Hello dear students, in this lecture of signals and system, today we are going to see initial value theorem. Generally, initial value theorem and final value theorem are also called as limit theorems. Initial value theorem is one of the basic properties of Laplace transform and it is suggested by the mathematician Pierre-Simon Laplace. Conditions. There are two conditions for existence of initial value theorem. First is the function ft and its derivative f dash t should be Laplace transformable. If t approaches to 0, then the function ft should exist. Mathematically, this can be written as limit t tends to 0 ft. This should exist. Now what is initial value theorem? If function ft and its derivative is f dash t are Laplace transformable, then limit t tends to 0 ft is equal to limit s tends to infinity s fs. So this is the theorem. Now we are going to prove it. So let us see the proof. We know that Laplace transform of f dash t is equal to s into Laplace transform of ft minus f0. Therefore, Laplace transform of f dash t is equal to s into fs minus f0. Here, Laplace transform of ft is indicated by capital Fs. Now by taking the limit s tends to infinity on both sides, we get limit s tends to infinity Laplace transform of f dash t is equal to limit s tends to infinity s into fs minus f0. Therefore, limit s tends to infinity Laplace transform of f dash t is equal to limit s tends to infinity Laplace transform s tends to infinity sfs minus f0. Now we know that the Laplace transform of ft is equal to integration 0 to infinity ft e raised to minus st dt. So here we have Laplace transform of f dash t. So limit s tends to infinity integration 0 to infinity f dash t into e raised to minus st dt is equal to limit sfs minus f0. As s tends to infinity, the limit of LHS will be 0. Therefore, we can say that limit s tends to infinity sfs minus f0 is equal to 0. Therefore, limit s tends to infinity sfs is equal to f0, which is nothing but limit t tends to 0 ft. And this is the required expression, or this is the required theorem of initial value. Thank you for listening.